At the Comet Group, we live by a pioneering spirit, great ingenuity, and an enduring passion for solutions that lead the way.
Welcome to the BPM Microsystems booth here at Productronica. I'm delighted to be joined by James Halava.
Yes.
Nice to meet you, James.
Thanks, Trevor. Good
Okay.
to be here.
Now, BPM's been around for a number of years. You're one of the leading companies in device programming, and you're now on your 9th gen. So tell us, what is new in your 9th generation?
So for 9th generation, we're supporting universal support for all device technologies. We brought forward the support from our 6th gen, 7th gen, and 8th gen. All those sockets are being brought forward onto the 9th gen platform. So it gives us a large library to support future devices on, and a big library of devices already supported on a new platform. Over 35,000 devices on this new 9th gen platform.
Right, okay, yeah, you always had a huge library, but your total library is even bigger than that, isn't it?
Yes, there's over 70,000 devices supported on all of our platforms. 9th Gen brings forward all the support we've done since around 2002 that we have our current socket card design, and that's able to be utilized on the 9th Gen.
Right, okay, great. So, on your recent upgrades, what sort of key things are we looking at? What speed increases?
Yeah, so 9th Gen, one of the key features that 9th Gen brings is support for the latest eMMC devices. We support the HS400 mode of programming for those devices. It's a high-speed mode, and we can program and verify up to 200 megabytes per second. So when we're having customers specifically in the automotive sector that are programming large files up to 32 gigabytes of data, they need fast speeds for programming to reduce the number of sites and sockets they need to get the throughput for their production.
So huge increases on the speed. What about the systems themselves? Because you're dealing with miniaturization all the time. Devices are getting smaller. What have you done to help with the handling side of the systems?
Yes, that's exactly right. What we're seeing, the trend is higher density devices and smaller package sizes. So handling those small package sizes becomes critical. So we've developed something that we call Whisper Teach, which automates the process for teaching Z on the part, and we eliminate the operator from needing to be involved in that process. So we're able to teach Z by hitting a button, press Whisper Teach, that goes down and it finds the top of the device, and automatically it will pick up the device and place it very precisely, accurately, and repeatable. So it's something that an operator would struggle to do to teach that device. We now automate that. It speeds up the process and gives the reliability that you need for that type of device.
What about accuracy of placement? How important is that?
It's critical because you have such a small device, you have a very small pocket in the socket, and we're also handling those parts from tape to tape. So we have to get them in the pocket, in the tape, accurately and aligned properly. We have a new vision system on the 4900 that's utilizing the latest cyber optics camera. So we're able to align the device on the fly accurately and at high speed, so we can have high throughput on this machine, up to 1,100 devices an hour programming the chip scale package. That's the fastest programming and throughput that you can get on a platform in the market today.
That's incredible. Now, a big part of your market is the automotive business. And automotive is, of course, the last thing they want is a lot of recalls. So traceability is absolutely critical. What are you doing to address the traceability issues?
So traceability goes from serializing the device, but we can also laser mark the device with a serial number, and you can have traceability back to the programming system it was programmed on, to the site that it was programmed in, down to the socket that the device was programmed in. So they have complete traceability all the way back to the socket that programmed the device. We also see a lot of need for encryption in the automotive sector. That's becoming more important, so we have a lot of features for serialization where we can actually go into the device, pull out data out of the device that's used to create a key in an outside server. And so we've got a very flexible system to work with a lot of different applications to make sure that our customers can implement a secure process.
Interesting, okay. And can you laser mark these at the same time as programming them?
Yeah, so it's all encompassed in the process where we'll pick the device out of tape, we'll program that device, we'll go over and inspect the device with 3D inspection, and then laser mark the device, and then it goes out to tape. And that laser mark, again, that can create the traceability with a serial number on the device, so that they can know when it was programmed.
Oh, that's incredible. James, I mean, device programming has come a long way since I first started in this industry, so it's great to see all these new technologies you're bringing in. And thank you for joining us today.
Oh, thank you very much. We're excited to be here. Thank you, Trevor.